Okay, thank God for what we've done. Now, in the previous class I had with you, where in the previous class I had with you, we're talking about. Let me get through my notes. Where I guess we're talking about cracking. We're talking about cracking and reforming. I made you to understand that cracking involves breaking of large. Between cracking, cracking involves breaking of large of petroleum into smaller molecules uh, while reforming involves the rearrangement of atoms in the molecules of petroleum to obtain branch and cyclic hydrocarbon. We also said cracking can be achieved either by heat or by the action of a catalyst. But reforming would always be in the presence of a catalyst. That's one of the differences. Another thing about cracking is cracking occurs at a higher temperature. Why? Because we are breaking large molecules. So it's going to be at a very high temperature. And than that, reforming might be high, but not higher than cracking. Another thing else is cracking is employed to increase the quality of petroleum. Sorry, the quantity. We use cracking to increase the quantity of petroleum. But when we talk about reforming, reforming has to do with the quality of petrol. Cracking has to do with we do cracking to increase the quantity of petrol. We need more petrol, so we get higher hydrocarbons, higher ones, and crack them into simpler ones because we need to increase the quantity of petrol. But when we talk about reforming, in reforming, we want to increase the quality of the petrol that we have gotten from cracking. Okay, the next thing we talked about, okay, I said we'll be talking to today is octane number or octane rating. Octane number or octane rating. Okay, so what do you understand by octane number? I guess I give you as assignment. Yes, so tell me, what do you understand as octane number?
Octane number is the measure of performance of petrol in the engine.
So is the measure of what?
Performance of petrol in the
Okay,
engine.
okay. The measure of the performance of petrol. Okay, I guess I have some videos. I'm coming. I'm trying to work on check the videos I have. Okay. Coming. Okay.
Hydrocarbons are class molecules composed of chains of carbon. Short.
Sorry, can you see this? Are you seeing anything?
No.
Okay. What about now? What about now?
No.
You're not seeing anything yet? Wow. What's wrong with this?
Okay. Yeah, I can see it now.
Oh, sorry, I removed it. How about now?
Yes, I can see it.
Okay. Let's just, oh,
Chains of carbon. Short, light chains like methane, ethane, propane, and butane tend to be gases. Long, heavy chains can range from viscous liquids to even solids. But it's the volatile liquids in the middle that are important for gasoline. When petroleum is pumped from the ground, it contains a mixture of various hydrocarbons. A technique called fractional distillation separates the hydrocarbons by length by taking advantage of the differing boiling points of each molecule. Since only the hydrocarbons from pentane to octane are used in gasoline, manufacturers can use a process called cracking to break large hydrocarbons into smaller ones, and isomerization to convert small hydrocarbons into larger ones, thereby increasing the yield of middle-length hydrocarbons. These molecules then make up the bulk of gasoline, along with a few additives. Most modern cars are 4-stroke gasoline engines. One of these strokes is a compression stroke, where the engine compresses a mixture of gasoline and air before using a spark plug to ignite it. Two of the most important constituents of gasoline, heptane and octane, behave very differently upon compression. If heptane is compressed even a small amount, it spontaneously ignites. Octane can be compressed a large amount without igniting. These characteristics led to the octane rating given to fuel at a gas pump. Gasoline's capacity to resist spontaneous ignition upon compression is compared to the capacity of a standard mixture of heptane and isooctane. For example, gasoline with an octane rating of 90 is able to resist ignition upon compression, as well as a mixture of 90% isooctane and 10% heptane can resist ignition. To make things a little more complicated, the octane rating at gasoline pumps is the average of two different values, a research octane number and a motor octane number. The RON is determined at a low engine speed of 600 revolutions per minute, while the MON is determined at a high engine speed of 900 revolutions per minute. If gasoline spontaneously ignites before it is fully compressed, high pressure builds up in the engine. This is called knocking because of its distinctive sound. While knocking, a car is much less efficient, and over time, this pressure can damage the engine. High-performance engines found in powerful cars compress the fuel-air mixture more than normal engines do, which is why they typically require gasoline with a higher octane rating. And really, preventing knocking in high-performance cars is the only reason to purchase fuel with a higher octane rating. An average car is built to run on gasoline with an 87 octane rating, and it will get the same mileage regardless of which gasoline is being used. But hey, there's an excuse to purchase the cheapest gasoline on your next trip to the gas station.
okay. Now, I don't think this was what I wanted. That was not what I wanted. Sorry. Oh, let me see. How did I get that other one?
Seating.
Sorry. Where's this thing I got? Oh, where is this? Coming. That was not what I wanted to show you. Okay, can you see this? Can you see this?
Yes, sir.
Okay.
Yes.
And octane numbers. At the end of this lesson, you will be able to describe octane number, describe cetane number. Since the development of internal combustion engines, inventions have been made to improve their efficiency. One of the primary aspects of which is to develop the understanding of the relationship between the engine and fuel that burns within it. The octane rating is a measure of a fuel's ability to avoid knock. Knock occurs when fuel is prematurely ignited in the engine cylinder, which degrades efficiency and can be damaging to the engine. Scientists discovered that some fuels knocked more readily than others. Experimental studies led to the determination that of the standard fuels available at the time, the most extreme knock was produced by a fuel composed of pure normal heptane, while the least knock was produced by pure isooctane. This led to the development of octane scale for fuels. Similarly, cetane scale was developed for diesel fuels. Octane number. Octane number represents the knocking characteristics, especially for gasoline in IC engine. The quality of gasoline or petrol determines the octane number. When gasoline is burned in a spark ignition engine, it produces power. A good quality gasoline burns smoothly without making any noise in the engine. When we burn bad quality of gasoline, it produces a sudden high pressure and it is not smooth all the time. Thus, the pressure waves or knock or detonation is formed in the engine. The octane number of a gasoline is a measure of knocking tendency.
Did you get that? The octane number of gasoline. Oh, you were not writing some things. Don't mind me. I thought you would get. I actually wanted you to get some notes from here before I continue. I'm going to play that again.
Since the development of internal combustion engines, inventions have been made to improve their efficiency. One of the primary aspects of which is to develop the understanding of the relationship between the engine and fuel that burns within it. The octane rating is a measure of a fuel's ability to avoid knock.
Now, the octane is, okay.
The octane rating is a measure of a fuel's ability to avoid knock. Measure of a fuel's ability to avoid knock. Knock rating is a measure of a fuel's ability to avoid knock.
Did you get that?
Yes, sir.
What? Read out what you have there.
Octane rating is a measure of a fuel's ability to avoid knock.
I didn't get that, please.
Octane rating is a measure of a fuel's ability to avoid knock.
Okay.
Knock occurs when fuel is prematurely ignited in the engine cylinder, which degrades efficiency and can be damaging to the engine. Scientists discovered that some fuels knocked more readily than others. Experimental studies led to the determination that of the standard fuels available at the time, the most extreme knock was produced by a fuel composed of pure normal heptane, while the least knock was produced by pure isooctane. This led to the development of octane scale for fuels. Similarly, cetane scale was developed for diesel fuels. Octane number. Octane number represents the knocking characteristics, especially for gasoline in
The octane number represents the knocking characteristics of gasoline. Okay.
IC engine. The quality of gasoline or petrol determines the octane number. When gasoline is burned in a spark ignition engine, it produces power. A good quality gasoline burns smoothly without making any noise in the engine. When we burn bad quality of gasoline, it produces a sudden high pressure and it is not smooth all the time. Thus, the pressure waves or knock or detonation is formed in the engine. The octane number of a gasoline is a measure of knocking tendency.
The octane number of gasoline is a measure of knocking tendency, and we know that the octane number determines the quality of the petrol. This shows that most times when we hear those knocks, when we hear those noise in cars, we know the gasoline is not quite good. It's affected already. Okay, let's continue, please.
N-heptane knocks very badly and hence its anti-knock value has been arbitrarily given 0. On the other hand, isooctane gives very little knocking. So its anti-knock value has been given as 100. Thus, if a sample of petrol gives as much of knocking as a mixture of 95 parts of isooctane and 5 parts of N-heptane, then its octane number is taken as 95. Octane number can be improved by different methods. Tetraethyl lead, TEL, is the most common anti-knocking agent added to improve octane number. Different methods.
Methods of improving octane number. Methods of improving octane number. Number one, we see, oh God, what did I do? Okay.
By different methods. Tetraethyl lead.
Tetraethyl lead.
Octane number is taken as 95. Octane number can be improved by different methods. Tetraethyl lead, TEL, is the most common anti-knocking agent added to improve octane number. Nowadays, octane number is improved by adding alkylates to gasoline.
Number two, adding alkylates to gasoline. Remember we talked about the alkyl group. Adding alkylates to gasoline.
Octane numbers for gasoline, which is used in automobiles, varies. The higher performance car require gasoline with a higher octane rating. The fuel with higher octane rating prevents knocking in high performance cars. Whereas an average car is built to run on gasoline with an 87 octane number will get the same mileage but will face knocking. Two common methods of rating gasoline and other spark ignition engine fuels are the motor method and the research method. These give the motor octane number MON and the research octane number RON. Research octane number method measures anti-knock performance under relatively mild operating conditions. The engine is run at mild load and low speed. Motor octane number method measures anti-knock performance under relatively severe operating conditions. The engine is run at severe load and high speed. Fuel sensitivity. The difference in octane number between the research method and the motor method octane numbers is known as the fuel sensitivity. Thus, fuel sensitivity FS equals RON minus MON. Generally, fuel sensitivity range.
Sorry, are you writing this part?
Yes, sir.
Oh, okay. Sorry, I didn't know. Let me know if you're done, please.
I'm done.
Okay.
RON is MON. Generally, human sensitivity changes from 0 to 1. It measures known characteristics of a fuel when condition of operation changes. Fuel sensitivity shows how a fuel behaves when engine's working condition changes. A low fuel sensitivity number usually means that known characteristics of that fuel are sensitive to engine geometry. The average of two octane number rating methods RON and MON is known as anti-knock index. Thus, anti-knock index equals RON plus MON by 2. Modern way to determine octane number.
So basically, go back.
Fuels
Okay.
of different grades are produced. It is anti-knock index equals RON plus MON by 2. Modern way to determine octane
No,
number.
Did you get that? Did you
can
get?
you go back again? Okay.
Known as anti-knock index. Thus, anti-knock index equals RON plus MON by 2. Modern way to determine octane number. When fuels of different grades are produced, it is customary to have them tested for quality in typical test motor engines using that fuel. This method is time-consuming and expensive. So, it has been replaced by more modern NIR spectroscopy. Based on a previous calibration, the octane number of the fuel is read out on the digital meter. Properties of fuel mixed with gasoline. If the alkane chain is short, then the octane number is high. However, the volatility of the hydrocarbon increases with a decrease in the chain length. The shorter alkane chains have to be mixed in petrol to lower their volatility.
Okay.
And increase the octane number of the petrol. If the alkane is more branched, then the octane number will be higher. Cyclic compounds have higher octane number than straight chain compounds. Cetane number is a related. The petrol. If the alkane is more branched, then the octane number will be higher. Cyclic compounds have higher octane number than straight chain compounds.
I say go back.
Okay.
The petrol. If the alkane is more branched, then the octane number will be higher.
If the alkane is branched, the octane number will be higher. Then cyclic alkane have a higher octane
Cyclic
number.
compounds have higher octane number than straight chain compounds.
Have you gotten that?
Yes, sir.
So the more branched the alkane, the higher the octane number. While a straight chain alkane has a lower octane number. Why? Because they are more reactive. Branch chain most times are more reactive, so they have greater octane number than the straight chain.
Cetane number is a relative measure of the time delay between the injection of fuel into the chamber and the start of combustion. Cetane number is the percentage of hexadecane in a mixture of hexadecane and 2-methyl-naphthalene, which has the same ignition characteristics as the diesel fuel under test. We can deduce the ignition quality of a fuel through its cetane number. A fuel with good ignition quality has a high cetane number where the ignition delay period between the start of fuel injection and the onset of auto ignition is short. A higher cetane number indicating a shorter ignition delay time usually means more complete combustion of the fuel. This translates into quicker starting, quieter operation with less diesel chatter, improved fuel efficiency, a reduction of harmful emissions.
Okay, we might not really need cetane number because it's not part of cetane number is not part of our own outline. Let me see. I'm coming, please. Coming. I think there's something else I want to check about. Okay, I guess it's the same thing. Okay, the same thing we just looked about. Okay. I'm coming. All right, now, oh, sorry, not this. This was SS2. Okay, the next thing we should talk about is the importance of crude oil and petrochemicals. We know the importance of crude oil. We know the importance of crude oil and petrochemicals that, in fact, one of the issues or one of the problems Nigeria is facing is that we do not know how to convert we don't make use of our petrochemicals. Petrochemicals can, in fact, China doesn't have crude oil, but guess what? China make a whole lot from the petrochemical industries. That means the aftermath of crude oil, which is using crude oil, petroleum to make other petrochemicals, they make a whole lot of them. Remember our plastics, our synthetic rubber, our insecticides, detergents, they are made from petrochemicals. Now, petroleums, one of the things we can use it to make, number one, it's very important that we can use this. We can use it, number one, to make a plastic. Plastic is from petroleum. Organic solvent like benzene from there. You can also make your rubbers, synthetic rubber, make it from crude oil, from petroleum. Insecticides, even our detergents are made from our petrochemicals. Now, synthetic fibers like nylon, in fact, nylon is from petrochemicals because they are polyethylene. You know, when we start talking about ethene, that's ethene, E-N-E, we see that all this polythene bag is from the word ethene. Poly is polymerization. So that means joining together of small ethene to make poly. When they become many, they become polyethene. That's how we call it polyethene bag. Now, even another importance of the oil industry is that it has provided employment. Most persons now work in the oil industries. And people, engineers, they find themselves in the oil industries. Um, I think, sorry, I want to ask you, in your school, your timetable, after carbon, what next? What next? What topic next? Okay, they've started. They've started.
This is my fault, man. I don't know what's going on.
Have they started?
I don't know. I didn't know.
It's just the code I have here. Just the code. Oh. Why did you say B? Tell me, what do you think are those things there? Number 3, what do you think are those things there?
Product of fractional distillation.
Yeah, you said what?
Product of fractional distillation.
Good. Okay. I don't. Do you think? Don't you think gas oil, diesel, lubricating oil? Don't you think they are products of fractional distillation?
Hello? Hello, uncle. Hello?
Hello, ma.
Hello? Good morning. Good morning.
Good morning, ma.
Hello?
I can hear
How
you.
are you? Sorry, oh, I was in a meeting. I was in a meeting when you were calling. Are you hearing me?
Yes, I can hear you, ma.
Hello?
Hello,
Okay, I
I
was in
can
a
hear you.
meeting. That's why I could not respond fast. I was in a meeting when you were calling.
Okay. All right, no problem, ma. to do. Okay. Okay. What? Okay. Number 3.
D.
D. Correct. Hematite is not. Correct. Okay. Uh, which of the following is a source of hydrocarbon? The 4. So which one is the source of hydrocarbon?
Slag. D.
Sorry, what did you say?
D.
B. Sorry, what's B? I'm not even seeing it. B. Marble. Sorry, is it marble? Okay. Slag. Are you serious? It's slag is source of hydrocarbon. Why did you say slag? Yeah? Why did you say slag? Tell me. Hmm? Yeah, why did you say slag is a source of hydrocarbon? Why? Yeah? Why did you say so? Now, do you know what a slag is? A slag has to do with that's waste from metals. So a slag cannot be a source of hydrocarbon. So which other one do you think would be the source of hydrocarbon?
Coal.
Sorry?
Coal.
Coal. Good. Coal is actually a source of hydrocarbon. Okay. Number 5. Crude oil can be obtained in Nigeria in the following places except. Can you guess that? Can you guess that? Yep.
C.
D. Kano, right? Did you say Kano?
Or
Actually,
C. Owaza.
Waza. Definitely, we know that crude oil is not in Kano. All these places are east, southeast. All these places are eastern areas, eastern areas. But we know that we don't have crude oil here for now. That's in Kano. All right. Let's discuss something on let's come back to chemical industry. Let's come back to chemical industry. Okay. Wow. Chemical industry. All right. I would soon. Okay, I'll just tell you something briefly about chemical industry because we are meant to have a meeting now. But let's just talk about chemical industry. Now, a chemical industry is an industry that uses the principle of chemistry to convert raw materials to useful products. Please write that. The chemical industry is an industry that uses the principle of chemistry to convert raw materials into useful products. Now, there are some factors we use in citing a chemical industry. A chemical industry, before it is being placed or erected in a certain area, one of the first things we look at is the nearness to source of materials. Number one, it must be close to materials. Now,
So you said chemical industry uses raw materials.
the principle of chemistry to convert raw materials into useful products. Uses the principle of chemistry to convert raw materials into useful products. Okay, I said we want to consider what are the factors to be considered when citing a chemical industry. What are the factors to be considered when citing a chemical industry? One of such factors I did mention was nearness to source of materials. Nearness to source of material. You can't have petroleum. That's why we'd always have most petroleum industries in South-South, Southeast, Southwest. Why? Because we have petroleum closer to those areas. So we can't have petroleum industry in Kano. It's not possible because it would be quite far. We might have a refinery there. We can have petrochemical industry, but a petroleum industry where they would drill for petroleum, we can't have it there. Number two, there must be power supply. Power of well supply is another thing. Power of well supply. Constant power is being generated there. Number three, human resources, the labor force. That's why we have humans, we have people living there. Number four, we also have the transportation cost would be considered transportation costs. Number five, we'd also have nearness to the market. Nearness to the markets. Number 6 is nearness to source of water. Nearness to source of water. Nearness to source of water. And the last one is a conducive climate. A conducive climate. Okay, have you gotten that?
Yes, sir.
Okay, please, I'm going to explain better. We are meant to have, we are already having a meeting now, so I'll quickly rush for the meeting and I will tell you, I have 1 hour left to take you. I'll tell you when I will come up again.
Okay.
Do we agree to that?
Yes, sir.
Okay, I'll chat mommy up again. We are having a meeting now. So I'll just quickly go for the meeting, and when we're done, I'll let her know when we're done so we could have the extra time. Or would you like us to come back again or till next time we meet? Let me
Come back again.
leave it to you now. Do you want us to come back again or till next time?
Come back again.
All right, so I'll come back again. All right, have a wonderful time.